Hey everybody, I'm Jerrod, dorminey. I'm the contemporary worship leader and set designer and many other tasks here at Frazer United Methodist Church in Montgomery, Alabama. And this past Sunday we did something really cool that we've never done before. We actually made it rain in the midst of one of our worship services, and I'm not talking about throwing dollar bills in the air. We actually made water come down from the ceiling in our worship services, just to help make the point of God's blessings are raining down on us all the time, and that we should just be in awe of God. And the illustration that Patrick used, our pastor, that he really used was just the idea of rain and how God makes water come up and evaporate, and billions of pounds of water are carried for hundreds of miles before God releases them out of the clouds in just the right time and the right order so that they water the fields and the earth and all of those things. And he used a lot of Psalm 104 for that. But I just want to show you the system for how we actually made it rain this week. It was a pretty big deal to make this thing, so I just kind of want to show you what we've got going on here. Please excuse the mess back here, and it's kind of dark, so just bear with me. Anyways, as you can see, what we've got here is a 45-gallon plastic trash can. In that is about, I don't know, probably about 35 gallons of water, probably a little less than that actually. In there, in that water, which is quite cloudy now, is about a 4,200 gallon per hour sump pump. What that does is that pumps water up here to this T where I have a ball valve. All of this is 1 1/4 inch PVC pipe. The ball valve will allow water to come through here and just recycle back down into, the bucket, into the trash can. And when I open that all the way, that means that water is simply just recirculating up in here and back down. So it's coming up, back, and just down. That's what it does when it's fully open. Now when I close that off some, what it does is it allows the water to go all the way up the pipe, 19 feet up to what was for a curtain, a sight curtain. You can see that up there. Now I took that all the way across about 50 feet. Yeah, it's 50 feet. It's 5 sections of 10-foot pipe. And for 42 feet of that, so starting at about 8 feet, sorry you can't see it there, starting about 8 feet up there, it's got 3/16 inch holes drilled every 3 inches. And those are pointing straight down. And we have to we close the ball valve off to about, I don't know, I guess that's about a quarter of the way. We close it off and it allows just the right amount of pressure to go up, and it makes it all the way to the end. And it doesn't come all out at once. It starts, it starts right here and basically works its way down, which is a cool effect. It's like how rain moves across wherever you are sometimes in a scattered rain, in a summer thunderstorm. That's pretty much what it does. From there it falls into a trough, which runs the full 42 foot length, plus actually a couple more feet on either end just to catch spray over. That trough is about 24 inches wide, and what it is, I don't know if you can see this, it starts about 3 feet high down there, and I created this out of 4 foot by 8 foot stage platforms that we had, and I just put 2x4 legs on all 4 corners, and I made it fall 2 inches for every 8 feet in length. And so on top of that, I put 2x4s standing up on their ends or on their sides so that they'd be 3.5 inches tall, and I made them 24 inches wide. Let's try and get you a better angle on this. If you can see that, it's basically 24 inches wide. And on top of that, I put this 4mm plastic stuff to make it waterproof. Well, I read a blog about somebody making a rain curtain, and they said they had so much splash from the water just landing on that plastic, and then it was so loud it was drowning out the performers at the time. So they got this Kevlar screen door material, or just like window screen material, and they tightened it over the trough. And what that does is when the water hits this fiber, it just disperses. Instead of hitting and splashing, it just hits it and disperses through it. And so that really has helped in quieting this down, but also it keeps water contained within just this 24-inch trough. It all falls and it runs right downhill, and it runs into this bucket right here, which is a 27-gallon basically storage container. And in that storage container I have another sump pump, the same size as what's in the big trash can. And this sump pump, as you can see here, it's in a lot less water, but it has the job of returning the water that lands in the catch. It returns it through this hose and back up into where we started from. Now, one of the problems I ran into with this, well, two problems actually, is the first pump that I used for here, thinking that it would be dealing with less water, was I put a 300 gallon per hour pond pump in there, and that wasn't moving water fast enough. This was wanting to overflow, and so I had to go back and get the same size sump pump as what's in the big trash can. Unfortunately with that is that it has this little, I don't know if you can see this, it's a float that's basically a valve that actuates when it turns on and when it turns off. Well, it's used for the usual sump pumps, or the sumps that they go in are usually deeper than this 27 gallon container, and so that float wasn't traveling enough distance up or down to actuate it. So what we had to do was we adjusted it to where the water would come up high enough and turn it on, but then it wouldn't drop low enough to turn off, if that makes sense. It would hit the bottom of the actual plastic container before it would turn off. So what I did, and you can't really see this, but here's a zip tie holding it. That's terrible. Let me get some light for you real quick. Hold on. Bear with me. Alright, you see the zip tie, and it holds to that point right there, which is almost it's close to where the actual pump is itself. And so when the water gets down far enough, it just kind of falls over and breaks over like that, and that allows it to turn itself off. That was the easiest way to fix the problem that I had. As you can see, I had a brick in there trying to adjust it, but that didn't help either. So we've got that right there, and that actually fixes it. It allows the water to float that valve all the way up, but then when it drops to a certain point, that zip tie basically just creates a break point in it, and when it tightens the zip tie enough, it just falls over and turns it off. So I know that's not exact engineering terms, but I'm not an engineer, so that's what you get. So anyways, here's the catch. Runs all the way up the distance of the stage, 42 feet. You know, the pipe up there, and then back there. So let me turn it on for you. Our lighting guy, David Montplaisir, he's our head volunteer lighting guy. He's the one that kind of figured out the lighting and everything for this, which really makes it pop. But on top of that, he figured out how to make, how to tie all of these pumps and everything into our lighting system. And so he controlled the whole thing from the lighting board. He turned the pumps on, turned the pumps off from the lighting board during the part of the service that we used it. It was really cool. I'll link to a video to show you how we used it during the worship service. But let me get this going for you real quick, just so you can see what we did. Alright, so here we are. I'm just going to power it up real quick. Leave the valve on the flow where it is, just so you know that you know what the right pressure is once you get it going. That way when you turn the pump on, it'll be going at the right flow and you don't have to worry with it anymore. So here we go, just plugging it in so you can get an idea for what it does. Pump turns on, water's traveling up, and it's raining. And as I said, it kind of moves across the stage. It goes pretty quick. Yeah. I know you can't see that real well, but it's raining the whole length of the stage. And then water is flowing back down into my return catch. And when it gets high enough, it'll actuate that pump to turn on, which will move the water again back to our start off where we started. Getting anywhere that it's not supposed to. It's all contained, which it has to be because there is electrical boxes and lighting and projectors and all kind of other stuff back here. So it all works like it's supposed to. So hope this helps. If you have any questions about how we've made this happen, feel free to contact me at Jerrod@FrazerUNC.org. Take care, have a good one, be blessed.